Hello friends, welcome back. So, so this is our another session on data structure and algorithms, where we will learn more about algorithms. Algorithms. In this algorithm, we will learn the different approaches to design an algorithm and control structures used in algorithm. So let's get started. So as we have already seen in our first data structure and algorithm sessions, what is algorithm? It is a set of rules that will instruct computer what to do and in which sequence the operation has to be performed. So typically the definition of algorithm is formally defined as procedure for performing some calculation. You can say that algorithm is formally defined procedure. Formally defined procedure for performing some calculation or performing some action. If a procedure is formally defined, then definitely it can be implemented using formal programming language. And such language is known as programming language. If a procedure is formally defined, then it can be implemented using a formal language, and such language known as programming language. In general term, an algorithm provides a blueprint to write a program to solve a particular problem. We can say that algorithm provides a blueprint to write a program to solve a particular problem. Okay, it is considered to be an effective procedure for solving a problem in a finite number of steps. There will be some finite number of steps, and that will define an effective procedure to solve a problem. That is, well defined algorithm always provide an answer and guarantee to terminate. What does it mean? Like, algorithm should be terminated. It should not like that it will be running and not executing and not solving any problem and not giving any result. It should not be like that. So a well defined algorithm always provide an answer and it's guaranteed to be terminated. Okay. Algorithms are mainly used to achieve software reuse. Once we have an idea or blueprint of a solution, we can implement it in any high level programming language like C, C++, Java, Python, or any other programming language, whatever you take. So here, this is clear that algorithm is not a programming specific. Algorithm is a formal defined procedure, and that can be implemented using formal language, and formal language can be C, C++, Java, Python, or any other programming language, whatever you use. An algorithm is basically a set of instruction. You can say that also. An algorithm is a set of instruction to solve a problem. It is not uncommon to have a multiple algorithm to tackle the same problem. Yeah, if one problem is there, it is not like that. One problem, one algorithm. No. One problem can have n number of algorithm. Can have a one algorithm, two algorithm, three algorithm. It depends on the modules. Okay, but the choice of a particular algorithm must depend on time and space complexity of an algorithm. but the choice of a particular algorithm must depend on time and space complexity. What does it mean? What is time and space complexity? Time denotes how much time a particular algorithm will take to execute. Time means what is the amount of time, that could be in second, millisecond, or whatever the measurement we take. So it denotes the time in which time a particular algorithm will be executed. And space complexity means defines or denotes the amount of your computer memory to execute an algorithm. So that is called time and space complexity. We will see in the next session. But here we will see about algorithm, how to design algorithm, what is the control structure of algorithms. We will learn all those. Time and space complexity we will learn in the next session. Okay. So how? So now, what are the approaches to design an algorithm? A complex algorithm is often divided into small units called modules. Definitely. If algorithm is very complex, it should be divided into modules, and that unit in which we are dividing, we call it module. The process of dividing an algorithm into module is called modularization. The key advantage of modularization is it makes the complex algorithm simpler to design and implement. If we have divided our problem, we can easily solve. That is what is happening in agile DevOps model. That is what happening in agile DevOps model. The problems will be divided into a sprint, and that will be implemented. So the same approach will be followed while designing an algorithm. The complex problem should be divided into small modules, and for that modules we can write an algorithm. So that is the advantage of modularization. If we do modularization, make a complex algorithm simpler to design and implement. Each module can be designed independently. Another advantage of modularization. Each module can be designed independently and that are not dependent on any other module. While designing one module, the details of one module can be ignored because they are not interdependent, thereafter enhancing clarity in a design, which in turn simplify implementation, debugging, testing, documenting and maintaining of the overall algorithm. It is very helpful. So that's why we can do modularization. So there are two approaches to design an algorithm. One is top down approach, another one is bottom up approach. Top down and bottom up approaches. So means we can create the module of algorithm in two ways: top down approach and bottom up approach. So as shown in this figure, you can see clearly here is a complex algorithm. You can see this is our complex algorithm. That complex algorithm will be divided into modules: module 1, module 2, module 3, like that. It will go for n number of modules. So if you see top down approach, it will go from up to down, and if you see the bottom up approach, it will go from down to up. Now what does it mean, top down and bottom up? Top down approach, a top down design approach starts by dividing a complex problem into one or more modules. Suppose we have one complex problem here. We have one complex problem. This is our complex problem. We will start dividing it first. That is called top down approach. Means we have on top we have one complex algorithm. we started dividing that algorithm into the parts, into the module. So these module can further be decomposed into one or more sub modules, and in this process of decompositions is iterated until the desired level of module complexity is achieved. We will dividing until we will not get the complex the module complexity is achieved, where we will see there is no complexity. Now we will stop dividing. So that is called top down approach. Top down design method is a form of stepwise refinement, where we begin with a topmost module and incrementally add modules that it calls. Therefore, a top-down approach. We start from abstract design, and then at each step the design is refined into more concrete levels until a level is reached that require no further refinement. Refinement is nothing but creating a new module. Yeah, we have seen one functionality, create a module for this one, another create module for this one, like that. So this is called top down approach. From the complex problem we will start dividing. But what is the bottom up approach in this case? Bottom up approach is just the reverse of top down approach. In the bottom up design, we start with designing the most basic or concrete module, and then proceed toward design high level module. Two approaches. First, we can take a complex problem, we can start dividing. Another one, what we will do, we will start from a basic functionality. We start with designing the most basic or concrete module. Like, yeah, this is a basic, like we have to create a calculator. Suppose we take an example, we have to take calculator, create a calculator. So calculator will have 4 basic operations, we know. So we will start writing the algorithm for each operation, for subtraction, multiplication, division, modularization, percentage, or any other, whatever you take, the functionality or operations that you want to define. So you will take the most basic concrete module. Yeah, one addition is one concrete module, you can write an algorithm. One division, one concrete modules, you can write algorithm. So this is bottom up approach. We will just take a starting by designing the most basic concrete module and then proceed toward the high level module. After that one, what we will do, we will combine all that modules and we will make a one complex problem. Another one, we take first a complex problem and we will identify which can be divided. Yeah, this can be divided from this one. From this one, what can be divided for a separate module, we will divide. Like that we will proceed. So the higher level modules are implemented by using operations performed by the lower modules. In this approach, sub-modules are grouped together to form a high-level module. Whatever we will create, say similar, like we have created for different operations, for different 4 operations we created for 4 algorithms for addition, subtraction, multiplication, division. Later on we will combine into one module where we will give the name like arithmetical operation module, like that. Okay, so this approach is sub modules grouped together in form a high level module. All the high level modules are clubbed together to form a high level modules. This process repeat until the desired complex problem is obtained. That's it. So last what we will get a complete structure of our calculator algorithms. Okay. So top down versus bottom up approach. Whether the top down strategy should be followed or bottom up is is a questions which one we should follow, that can be answered depending on the application at hand. We cannot say like which one we should follow. It depends on your application. It depends on your application. While top down approach follow a stepwise refinement by decomposing the algorithm into manageable modules. The bottom up approach on the other hand defines the modules that are grouped together. Several modules inform a new high level module. It depends on your application. Top down approach is highly appreciated for the ease in documenting the modules, generating the test cases, implementation of a code and debugging. However, it is also criticized because the sub modules are analyzed in isolation without concentrating on their communication with other modules or on reusability of components, and little attention is paid to data, therefore ignoring the concept of information hiding. Although the bottom-up approach allow information hiding as it is fast identifies. Why? Because from bottom-up approach, if we are going, definitely information will be hiding, because all modules are separate. They are not dependent on any other module. If another module wants to use this module, they have to just call the specific method and they have to pass the data and they will get the result. They don't know internal structure because internal structure will be defined as per our algorithm. But in top down approach, what we need to do, we have to define the structure also. We will know the structure. Yeah, this much functionality it will do and how it will do. Okay, what has to be encapsulated within the module, and then provide an abstract interface. Define a module's boundaries as seen from the client, but all this is difficult to be done in a strict bottom strategy. Some top down activities need to be performed for this. Okay, all in all, design a complex algorithm must be concentrated, because proceeding according to a fixed pattern, but should be a blend of top down and bottom up approach. Okay, any approach, whatever you wanted to divide a complex problem into modules, or you want to take the basic functionality or basic what you call that one, or any basic component, if you want to design, then you can design in that way also. It's up to our choice. Next one is control structures used in algorithm. What is control? In our Java programming language, we have seen there will be some conditions like if else condition, while, do while, for loop. So what are all those? Those are controls. We want to control the flow of an program execution. I want to control the flow of a program. How I can control? Using if else conditions, or using for loop, while, do while, or any other loop, or we can use the switch statement also. So that is the controls. So control structures used in algorithm. How we will define the controls in our algorithm? We have to see that one. So as an algorithm has a finite number of steps, yeah, definitely algorithm will have a finite number of steps. It will not have infinite number of steps. Some steps may involve decision making. Now what is decision making? Same, decision making is nothing but the controls only. You have to make the decision whether I have to execute this code or either have to this code. That is a decision only. If A is equal to B, if A equal to B, then please execute this one. Otherwise, else part, execute this one. If A is not equal to B, it means that only. So that is a decision making. And repetition is what? Repetition is like print the first 100 number from start from 1 to 100. That is a repetitions only. One thing we can write all the lines one by one. Another one we can write in a repeat. We can write a loop. Repetition is nothing but a loop only. So broadly speaking, an algorithm may employ one of the following control structure. This can have a sequence. If it is a sequence, or this can have a decision. Decision is what? Decision is your if else conditions. Repetition is your loops, whatever you use in your programming. So so what is sequence? By sequence we mean that each step of algorithm is executed in specified order, same order. If you take this example, what this example is doing the sum of two numbers only. Input first number as A. From step 1, what you understand from this one? From step 1, what you understand? Input first number as A. Now here A is a variable. A is a variable that is used to take the first number, or you can take input from any source, from keyboard, from file, or from anywhere. So input input first number as A. Okay. Input second number as B. B is another variable where we will take another input number. Now set sum is equal to A plus B. So now set sum. Sum is what? Sum is another variable. That should be is equal to A plus B. And print sum. And then end. So this all the steps is happening in the sequence only. There is no if else condition, no loop, nothing. That is just a sequence. So sequence means each step of algorithm is executed in a specified order. Whatever the order is specified, in the same order all the steps will be executed. That is called sequence. So this is our algorithm here. Next one is a decision. What is decision? Decision you will make. Decision statements are used when execution of a process depend on outcome of some condition. For example, if x equal to y, then print equal. If x is equal to y, print equal. So that the general form of if condition can be given as if condition then process. So here a condition on the context is an statement that may evaluate to either a true value or a false. In the above example, a variable x can be either equal. So here in this way, either x can be equal to y or cannot be equal to y. It depends on the values. X and y, it depends on their value. So a variable x can be either equal to y or not equal to y. However, it cannot be both true or false. It can be either true or either false. If the condition is true, then it has to process the execution. A decision statement can also be started with the following manner: if condition, then process this one, else process this one. Simple. If condition, then here you can give a process. You can write here then else process 2. Other codes you have to execute. The form is popularly known as if else construct. Here if the condition is true, then process 1 is executed, otherwise else process 2 is executed. So from here you can take from this Example you can understand. Step 1, what is happening at step 1? At step 1, input first number as a. We will take a number in variable a. In the second step, we will take a input of second number as b. Inside b variable, we will take the input of second number. And step 3, here is the condition: if a equal b, print equal. If a equal b, it depends on the value. What is the value we have input? We have taken input from keyboard or file. It depends what is the value we have entered. Either we can enter a 10, b 5. In that case, what will be? A is not equal to b. It will come to else block. If a value is 5 and b also value 5, then in that case it will print equal, because it will go for this first line number 3. So this completely is step 3 only. This if, else and end of if is complete one step. Either it will be executed this print not equal, or either it will be execute print equal. And after we have to end of if, and step 4 will be end. That's it. So this is the decision making statement. Next one is the repetition. What is repetition? You have to repeat the loops. You have to repeat a particular steps n number of times. You have to repeat a step n number of times. So repetition which involves execution one or more statement for a number of times can be implemented using construct such as while, do while, for loop. We can use this one. So these loop executions one or more step until some condition is true. One way, if I say print my name 10 times. So what is the first solution? You can write 10 system.out.println statement 10 times. You can write, and 10 times you will print the name. This is the one solution, but you have to write this. You have to repeat the same statement. You are repeating the same code every time. It is not a good practice. Instead of that one, simply you can write in a loop. So only one statement you will write, and that same will be executed. So repetition involves execution one or more steps for a number of times, can be implemented using constructs such as while, do while, for loop. These loop execution one or more steps until the condition is true. Suppose if you see this example, initialization is nothing but the set I is equal to 1. You just set I is equal to 1, n is equal to 10, I is equal to 1, n is equal to 10. So this is a one step only. Is it nothing but the initialization I is equal to 1 and n is equal to 10, two variables. In the step 2, repeat step 3 and 4. Repeat step 3 and 4 while I less than equal to n. I less than equal to n. Print I. In third step, what it is doing? First it is printing I. Then it is setting I is equal to I plus 1. So it is repeating steps third and fourth. First it is what it is doing. Now you can write the algorithm. You can write the program for this one. What exactly the program structure will be? Inside a loop, first you will print I. Inside loop will be what? Loop will be from I to n. If you use for loop increment also, you don't need to do, only just print statement you need to do. If you using while loop, then definitely you have to use do increment manually. Okay, so print I, and I is equal to I plus 1, and end of loop, automatically it will end of loop, and then it is ending the algorithm. That's it. So this is called repetition. So this is control structures used in algorithm. Okay, so three control structures are there. One is sequence. In the same sequence it will be executing. Another one is decision making. It will execute depends on the conditions. Third one is the repetition. It will execute the same statement multiple time on the basis of condition only. Okay, so this is the algorithm, approaches to design the algorithm, and control structures used in algorithm. In the next session we will see time and space complexity of the algorithm. So I hope you like this session. Please subscribe my channel and we will see you in the next session. Till that, bye bye and thanks for watching.